Okay, so in this video, we're gonna learn. This is the only video you need to learn about binary search for the theory and the code part. But I'm gonna code in Java, so yeah, you can find many codes online. So yeah, let's do it. So tip to remember is you can always. I don't think always, but most of the time you're gonna use binary search on a sorted array. So if there's a problem about like a find element in a specific element in a sorted array, what are you gonna use? You're gonna use binary search. But I mean, not every time, but yeah, it's you know your mind should go there first. So for example, let's do an array. So for example, 3, 5, 6, 11. Let's do 15. Sorry for my handwriting. 19, 22, and 31. Yep. Now let's see. We're gonna check if 19 exists or not. So these are target element. And step 1 of binary search is to put 2 pointers to the very end of the array. So this is a start pointer. These are end pointer. Now what we're gonna do? We're gonna find the mid. So how you can find the mid? So it's basic math, right? So we did it in high school. So start plus end divided by 2 equal to mid. Now, are you gonna add 3 plus 31? No. The start plus is the index. So this is the 0th index, this is the first index, this is the second index, this is the third, fourth, fifth, sixth, and 7th. Okay, so we're gonna do 0 plus 7. What can we get? 7 by 2. Now the integer division, not the floating or double division. So what is really is 7, 3, my bad, it will be 3. Now we're gonna check what is in third index. Okay, we have 11. So now this is the mid. Now second step, we're gonna check is our target greater than the middle element. So tell me, do you think 19 is greater than 11? Of course. So when our target is greater than middle element, we're gonna put our start pointer here. You can see our start will now be here. Now we're gonna apply the same formula in this space, this breathing space. Sorry, my bad, breathing space. This space right here. So now start pointer is here, end pointer is here. So same formula, 4 plus 7 by 2. What will be 11 by 2? What is the integer division of it? 5. So now 5 is our middle element. Now we're gonna have a condition in our code that is our target equal to middle element. And if it is, we found our target and we're gonna return the index. Return the index, so return 5. Like we will get the answer 5, and that's it. That's the whole thing. A binary search. People overcomplicate these things. I don't know these days. That's it. Now I'm gonna show you another example. So let's see. Let's do this color. So 2, 5, 9. I don't know, like 12, 14, 17, 23, and 28. Yes, that's good. So now what was the first step? Remember. So it was to put a start and end pointer right here. Okay. Now indent the indexes. So 0, 1, 2, 3, 4, 5, 6, 7. Same as last time. So we're gonna add a different one to to get something unique. So this is not the end pointer. This is the end pointer now. End pointer right here. So now choose a target. Like for example, if I want to check 9 is there or not. This is our target element. So the first step After that was to and the mid. So mid will be start plus end by 2. So 0 plus 8 by 2. What it is? Like 4. Okay, so this is our mid element. We got it. Now the second and most important step. Is our target greater or less than the middle element? Now tell me, is 9 greater or less than middle element? Of course, it's less than middle element, right? So we are gonna put the end pointer, like the end pointer, to middle minus 1 element. So the end pointer will be now here, and now our working space is this. We're gonna apply the same mid formula here, here. So now start is 0 plus 3 by 2. So 3 by 2, what will we get? Integer division 1. So this is our middle element. Okay, so now we can check again. Is our target element greater or less than middle element? So is 5 greater, is 9 greater than 5? Of course it is. So start will be here and end will be here. End will be there as well. So now I'm gonna check 2 plus 3. Same. These are working space now. So 2 plus 3 by 2. So it's 5 by 2. The integer division will be 2. Now we have that condition. Remember, if target is equal to middle element, because this is our now the middle element, right? Then look 2, 2. So we found our element right here, and that is binary search. That's it. Like, I hope you get the theory part. Now I'm gonna do the code. Let's do the code part. So what we're gonna do is we're gonna let's like working functions. So we're gonna create a function, search, and we're gonna array and the target, the parameters. Now, what was the first step? So it was like, what was it? So the first 2 pointers. So start will be what? 0, because it will be in the first, and the other pointer will be the other end. So in end be r and 1. Now we're gonna start the loop. While start 10 is the best condition. Now we're gonna find the mid, and it will be what? Start plus end by 2. My bad. Okay. Now there's a catch. Sometime maybe like it can happen that this thing like can exceed the integer memory or integer capacity. So we have to use a different formula. So we're gonna use start, my bad, start plus end minus start by 2. You can do the math, and this can never exceed teacher memory. So, okay, now we are gonna find, oh, the mid is done. Now we have to use the condition. If our mid is greater than, my bad, what am I even doing, man? Please. If a target greater than your mid, and what we're gonna do? We're gonna do start equal to mid plus 1. Remember what we did? So here, look, we put a start here when it's like greater than, right? So yeah, that's the thing. Okay, so and now, you know what? You can put the first condition, the main condition here. So if a target equal to mid, return it, else if a target is greater than mid, sorry, my bad, there are, what am I even doing? permit. So start it 1 and okay. So now the other condition was else and will be net -1, and that's it. That's all that. So loop, if we don't find anything, we're gonna return -1. That's it. That's exactly it. Look, for example, error. For example, this is this example. Like 3, 5, 6, 11, 59. Okay. 3, 5. What is the other one? 15, 19, 22, 32, 31. Okay. And we're gonna enter final search, ARR, target is 19, cloud, and run binary search. Markup -1. What is that? Let's see. Oh, my bad. Look, so 0, 1, 2, 3, 4, 5 is the fifth index. You get it, right? And this was that. So the whole binary search. For example, if we wanted to find, to say like 5, so it should be on 1, right? So let's run that again. Look, it's in 1. First index. Okay. So now practice it. Practice writing the code. Look, if I'm making mistakes, even like after practicing it like 20 times. So yeah, practice it. I would say 5 times. Write the code. Okay. The more you practice, the more you get it. So now do another example, like 31. Last one. So 0, wait, 0, 1, 2, 3, 4, 5, 6, 7. Forget 7. 7? Yes, we are getting. Okay. So that was the whole binary search. You know what? I can tell you also the time complexity of it. So the best guess, like we can find. So the best guess, like for example, 2, 5, 9, 11, 13, 15. The best guess will be we find the middle element. The middle element is our target, so that's the best case. So we'll get the time complexity of over 1. Now, so this will be our best case. Now our worst case, what will be the worst case? Tell me. The worst case will be we didn't find the element. We couldn't find the element. So after all those conditions, we couldn't find the element. And the complexity will be O of log n. You can do the math, right? Or I can make a separate video on how we get log n. So yeah, that's it. I don't need to worry about it. You just have to know these things and just do a little bit of, or I can make a video on time complexities or where I can explain the things. So that's our whole binary search.